Hey everyone! So in this video we are going to be covering how to add matrices together, and we'll first start by learning how to identify dimensions of a matrix, and then we'll move on to covering some of the common question types you're going to see with these problems. So make sure to stick around for the entire video to catch all of those. And if you enjoy this video, consider watching some of my other lessons on my channel. I'm going to soon be posting some subtraction and multiplication problems for matrices as well. So without further ado, let's get started. So when identifying the dimensions of a matrix, you have to look at things in terms of rows and columns. So for example, in this one case, we have 2 rows and 2 columns, and this is a good way of differentiating between the two. So think about the columns in the Colosseum, and think about like Rome, for example. We have these columns like this, and excuse my drawing, my great drawing here, but we have like a column, and we have, or in this case it's actually an arch, but we have these columns, these pillars that are holding the foundation up. So in this way, this is considered a column. This as well is considered a column. So we go about identifying matrices in the same way. So we know that there are 1, 2 vertical columns, and we know there are 1, 2 horizontal rows. So columns, good way to remember this, just columns. Yeah, there we go. And then those are vertical, and rows are horizontal. So this is the key to remembering this stuff as we're moving forward. So here, the way that you would write something like this is you would say this is a 2 by 2 matrix. And you might even have a bracket around this. So now let's move on to this section right here. So I like numbering them on the top. I find that's a very good way of labeling this. So these types of problems. So if we write 1 here, 2, and 3, and we go 1, 2. Also another point, you normally start on the top left. When I do this, I start at the top left corner, move down, and move across. So do that as you're moving forward as well. So we have 1, 2, 3 vertical lines, meaning columns. So this, by the way, this is the row and this is the column. So in this case, we know there are 1, 2, 3 columns. So that's going to be our last value. And there are 1, 2 rows. So 2 by 3. That's what this is. Now in this case, again, let's start from the top left and move across this way and down this way. So we have 1, 2, and 1, 2, 3. So here we can count 3 rows because they're going across. So we're going to start this with a 3 by 1, 2 columns. So now we're going to move on to some simple addition practice. So here we have a few problems. We have a plus b, a plus 2b, and a plus 1/2 b. So whenever you have a number, a whole number, fraction in this case, in front of a vector or a vector set, a matrix, you want to multiply this value inside of the matrix. So we're going to get to these in a second. Let's first start with a plus b, but just know we are going to cover this in a second. So a plus b. In this case, this section of matrix manipulation is very straightforward. You take this column here, this column starting this way, and this row starting this way, and you add it to the value in the corresponding column and row. So this is column 1, this is row 1. So we're going to add it to the value in column 1, row 1 over here. And later, when we're doing multiplication, this is going to be a little bit different. It's not going to be quite so straightforward, but this is how we're going to go about the addition part of matrix addition combinations. So 2 plus 5 would be in the first. So we're going to add these two together, and that's going to be the new column 1, row 1 value. So we're going to, what I like to do is to write 2 plus 5 in parentheses in that one slot. So I know that this value, it's going to give you one value, and I know that that's going to be the new column 1, row 1 value. So I'm going to do the same with this. So 3 plus 4, then 4 plus 1, and then 1 plus 2. Then we're going to simplify this, and we're going to get 7, 7, 5, and 3. So, yep, this is the right answer. So now moving on to a plus 2b, we're now going to do the exact same thing. We're not going to change anything with a because this value has no scalar multiple in front of it. But with these, we're going to multiply each of these individual values by whatever this number is. So in this case, I would recommend keeping this structure. So when we're doing this, we're going to have a parentheses. I'm actually going to, I'll keep it as a parentheses for now. So 2, because that's this value that's unaffected in the A matrix, plus 5 times 2. So I'm going to write it like this. And then I'm going to move on to the next one. So we have 3 plus 4 times 2. Then 4 plus 1 times 2. And then this last one, 1 plus 2 times 2. So when we write this, when we simplify, 5 times 2 is 10. 10 plus 2 is 12. And then 4 times 2 is 8, and 8 plus 3 is 11. And then 4 plus 2 is 6, and 1 plus 4 is 5. So that should be right. 12, 11, 6, and 5. Yep. And you do the exact same thing here with the fraction as well. Even though you're theoretically dividing, you're multiplying a fraction. Anytime you're dividing something, you're multiplying a fraction, essentially. So that's what we're doing here. So we're going to keep the first value the same, so we can actually write it like this. We can make a parenthesis, just a big one to encompass everything. And we can write all of the values for A in first, since we know that's not being affected. So 2, 3, actually, this would be 4. 2, 4, 3, 1. Yeah, so this all matches our matrix up here. So we're going to now put a plus for each of these. And we're going to say 1/2 times 5, so that's 5 halves. And then we have 1/2 times 4, which is 2. So 4 divided by 2, I'll just write it like this for now. And then we have 1 times 1/2, so that becomes 1/2 here. And then we have 1/2 times 2, which becomes 1. So So we're going to add these now. So 2 can be rewritten as 4 over 2, because that still divides to give you 2 as a whole number. So 4 over 2 plus 5 over 2 is 9 halves for the first column, first row value. Then we have 3 plus 4 halves. So we can just simplify this. We know 4 halves is 2, so 3 plus 2 is 5. 4 plus 1/2. We know that is the same thing as rewriting 4 as 8 over 2. So 8 over 2 plus 1/2 is 9 over 2. And 1 plus 1 is 2. So you check, 9 halves, 5, and 2. Yeah, so this is how you go about these kinds of problems. Now we're going to move on to the next section. So in this problem, we are given the matrix of A, and we're given the matrix of A plus B, but we don't know what B is in this case. So the best way of going about this is to treat this like a system of equations, where we're going to have 5, 7, 9 and 10, which is the a value, plus a whole set of x values. We'll call this x1, 2, 3, and 4 is equal to the a plus b, which is 7, 12, 12, and 11. So what I'd recommend doing is to treat this in a similar way as you would when you would add. So you know that normally what you would do is you'd take this value, so column 1, row 1, and we take this, which is column 1, row 1 again, and we would add these together, and we'd get this, which is in the same slot. So what we're going to do here is we're going to say 5 plus x1 equals 7. And we can solve for x1 in this case. So this gives us x1 equals 2. So let's do the same for 7 plus x2 equals 12. For the row 1, column 2 slot. So this equals 12. So let's subtract by 7. So that would be 5. So, sorry, not x squared. That would be a little bit different. Yeah, x2. So x2 equals 5. Now let's do x3. So that would be 9 plus x3 equals 12. We subtract 9 from both sides, and we get x3 equals 3. Now let's solve for x4. So we know we would write it as 10 plus x4 equals 11, and we'd subtract both sides by 10, and we get x4 is equal to 1. So now that we have these values, I'm going to clean up some of our space here so we have a little bit more room, since we actually have our values now. So clean this up a little bit. And from here, we can say that b, sorry, okay. So b equals 2, 5, 3, and 1. So that's how we solve this problem. And let's move on to the next section. So in this problem, we're given a, let's first test our knowledge. So we know that this is 1, 2, 3 columns, and we know this is 1, 2, 3 rows. So this would be written as 3 by 3. This is the type of matrix this is, and that's the same for this and this. So we know it's a 3 by 3 matrix, which is a little different than what we've been working with so far, but it's exactly the same. You say, okay, here's the value in row 3, column 1. We know this value is 2, and in row 3, column 1 over here, we know the value is x in this case, and we know that row 3, column 1 here, the value is 5. So you just add things in the same way based on the designated matrix point. So in this case, we have a similar equation to the last one, a similar problem set, but this time it's a little bit more complicated because it's a 3 by 3, and we're just solving for x and y here. Now, if they give you something like this, really we need to solve it the same way that we did before. So we know that this, and we need to treat each of these as their own system of equations. So we can treat this row 1, column 3, y. We can write this here. So y equals, one way you can write, you might see this written, is you might see a, and then row 1, column 3, plus b, row 1, column 3, equals a plus b, row 1, column 3. So this is essentially what we're doing here. So when we say y plus 4 equals, I'm just looking at the top right corner of each of these matrices. So y plus 4 equals 9. You can subtract 4 from both sides. and I get y equals 5. And when I do the same thing, so that's what this is right here. So when I do the same thing, I'm going to do that for x, but I'm going to give us a little bit more room here. So I know that I'm looking now at the bottom left, bottom left of each matrix. So 2 plus x equals 5. So I'm going to subtract 2 from both sides, and we're going to get x equals 3. So we know that x equals 3 and y equals 5. So this is going to be a little bit different when you're doing multiplication, but specifically for addition and subtraction, which I will cover in another video, you want to make sure that the dimensions of each of your matrices are the same in this case. There are ways of manipulating these later down the road, but that's more advanced, and we'll get to that eventually. So anyways, if you enjoyed this video, consider leaving a like and subscribing, and I'll see you next time. Thanks for watching.